Welcome to the next part of the SummerAcademy 2.1.5 Linters. By the way, if you like what you see, make sure to subscribe. Generally, linters are static code analysis tools that can help us in a variety of aspects. So there is the syntax, there's the grammar, there's style, there are depreciated things, and all of this I want to show you in a concrete example. Let us start by using a syntax example. So with a syntax, what we mean is every language defines a set of, let's say, words or tokens that are actually bound to various meanings within the language. So there are operators, there are variable definitions, there are expressions that you can have. And what a linter can do is literally going through your language and identifying which element belongs to which. And this then, in combination with the grammar, as we will see in a second, might end up to point to typos or misspellings or stuff like this. So in my example here, what I have is a function, and I actually altered the function. So I misspelled the word function here. And as you can see, with the syntax highlighting already, you see that function no longer has this dark blue, it has now more this light blue, which means it's now identified, the word function is now identified as a variable, which obviously is on the wrong position here. So there should not be a variable. So, and with this, we already know there's something wrong here. The developer did not really express the intent correctly. And we already know that we have to change something. My next example is about the grammar, as I already mentioned before. And you see again good and bad, and maybe you ask yourself what is bad on the bad side. I give you a second, maybe you pause the video and find it out yourself. Okay, here comes the solution. So the grammar in every development language defines the combination that you can do out of tokens. So what combination of operators, of variables can you actually, so to say, build up to express your intent as a developer towards the machine by using the programming language. And the bad example here adds an expression into an if statement. So the if statement, the language here, expects within the if statement only an expression that delivers either a truthy or a falsy value, and according to either the truthy or the falsy, the if is executed. But what the language finds here is there is another expression in here that doesn't have to do anything to do with the truthy or falsy. And as you can see, this is already flagged. It says, no, this is not allowed within JavaScript. So it is beyond the grammar. And this is another thing that linters can do. They know the grammar of the development language. And with this, they can also find these kinds of bugs. Next, we have a style example, and I think it speaks a bit for itself. On the left side, you see the example that I found in the internet. So this is copy and pasted from a public available repo. And on the right side, you see my rewritten version of it. Obviously bad from a style perspective. Why? Because I reduced the function name and the variable name to something that is no longer readable. I compressed the code into a few lines, so took away all of the indentation that helps me to read and understand what is really happening there. From a functional perspective, all of this is nice. So syntax is okay, grammar is okay, all of this works. But what linters can do now is they can be fed with rules that reflect style guides. So for example, the Airbnb style guide in JavaScript. And with this, I can enforce certain rules that help me to keep my variable names readable, to keep the function names readable, to limit the amount of parameters that are going into a function. So stuff like this, I can quote unquote enforce in a way. And this helps on two dimensions. So the first dimension is it helps the person that will read the code behind you. And by the way, that might be yourself in the future. The other side is also that it helps to make a cohesive body of code. So the different authors, different people of the team, they might have their different style, but as long as they keep on the style guide, it is easy for every member of the team to read any code that came out of the team because it's cohesive. It has the same style. So keeping a style is actually quite important, not while writing the code, but maybe while reading the code later. And linters can help you. My next example is a code smell. And my next example is what is called a code smell. So the idea behind that is there are things that are syntactically correct, the grammar is okay, maybe even the style guide is okay, but there are typical problems that developers do that still are okay with all of these, but still show that probably you did not intend what you're doing here. So maybe you already had a look at the example here and you pointed out where the problem is. And the problem is actually in the first if clause. You can see operator equals and then the string plus. This is a valid operation. It will be positive. And after that operation, after this if clause, operator, by the way, will be the string plus. On the flip side, it smells because it seems like this is not the intent of the developer. It is not the intent of the developer to set the operator variable and to always have a truthy if statement. So while this is syntactically okay and it will execute without a fault, it smells that there's something wrong in here. You probably forgot a few equal signs. And this is a typical problem that happens very, very often because in the hectic of typing, we forget to type all 3 equal signs. So these are code smells, and linters, again, can help us to find these kinds of issues, these kinds of problems. So my last example is stuff that is no longer or not yet supported. And especially in the JavaScript world, you have the situation that the standard is actually evolving very, very fast. Maybe so fast that even the runtime environments cannot keep up with it. For that reason, we have something that is called Bubble, a transpiler that we will talk about more in the next part of this course here, that literally does nothing else than using a later version of the language, which is then, so to say, transpiled, so to say, compiled from one source code to another source code in a earlier version of the language that then can be run on the environments that we have. So we are compiling JavaScript to JavaScript, but we are going backwards from a version history. And linters can help us to point out when we have functionalities, for example, as we have it here in my example. Here we are told that const is available with ECMAScript 6. And if we are having an infrastructure that is actually earlier than ECMAScript 6, we cannot use const. We need to have a transpiler in between so that the infrastructure can actually interpret what it gets here. So this is one of it. The other one is obviously that if you have functionality that is no longer or should no longer be used, and this happens a lot in the JavaScript world since also the libraries are moving forward very, very fast. Might it be Vue, might be React, and things are moving so fast that you sometimes are asked no longer to use certain constructions, but rather prefer other ways of doing things. And this is something where linters can also help you with. So now that I picked so much on this little piece of code that I found in the internet, I think it is only fair if I show you how I would have done it, and you can pick on me in the comments below. So here we are in Visual Studio Code, and this is my implementation of the same piece of code that you saw before. So what the application or the function here really does is it gets 2 operands. It has an operator which either can be plus, minus, multiply, or divide, and then does the calculation out of this. So what I would do a bit differently is I use a library called chai to have a command called assert, and that helps me to express my intention as developer a bit better. We will see in a second. So then I have a comment up on top here. I define the function calculate. I don't think I need to explain what calculate really does. I think it's quite obvious. So I only define what the operators are. First operand, it is a number, it shall not be null. Second operator, same thing, operand, same thing. And then comes the operator, and this shall be a single character, and it has the range plus, times, minus, and divide. So then I have the function itself, function calculate. Here are the parameters of it, and you see here I'm using the assert, and I'm literally enforcing what I did up here in saying the first operand shall not be null and it shall be a number, and the second operand shall not be null and it shall be a number. And I do the same thing for the operator. I check on isString. I do not check on the range because this is actually something that already will happen inside of the calculate function. So then I define result, which is the variable that keeps the result, and I initialize it with the second operand, which is something that is part of my requirement. So I did this. And then I'm using a switch case operator instead of a concatenation of if then else. Why this? Because in my perspective, this so to say expresses my intent that I will use always the same expression here, the operator, and there are different cases that I break out and look at the results in here. If I always have an if then if else statement, the if could always be different, and here I make clear that it's the operator and I decide upon the operator only. Then I have the case result is a plus, the case minus, the case times, and I have the case division. And the case division is a bit special. And the reason for that is that obviously division by 0 is not what we would like. And since we are talking about numbers here and floating point numbers, 0 can be something close to 0, can already lead to floating point imprecisions, and we need to make sure that we keep this in check. So what I do here is I literally say I want to have the absolute of the second operand, and if this is smaller than my precision threshold, I return not a number, because I perceive this is a 0 and I would divide by 0. Otherwise, I really do the operation. And then I have a default, which throws an exception. Because if the operator is not, as we defined it up here, in the range of these 4 characters, it was an illegal operator. And then I have a single return statement that returns the result. This is, in my perspective, good to read. It expresses the intent. It is defensive programming because it tests on the assumptions that I made with the incoming parameters. And the last point that I would put on top of that is actually the tests. So I have some tests here where I literally call the function and check if the function, so to say, behaves accordingly if I send tests in. Obviously, I would also have a test by dividing by 0, for example. I should have more tests here, but this is just an example on how these tests should look like. So now you have seen my way of doing things. Criticize me in the comments below. I am always open to learn. There's always something to make better, no question about this. So with this, I wanted to show you some of the goodness that linters can bring to the table, and I want to make sure that you use one. Please use linters. ESLint, for example, in the JavaScript world is a super good tool, and I would suggest everybody should literally use that within the IDE. So this was it for linters. Tomorrow we will talk about compilers, and you might ask, JavaScript compilers? Why should I care? I think you should care, so make sure to tune in tomorrow to learn about compilers in JavaScript.